All right, guys, today we're going to learn how to take everything we've learned so far and be able to graph a polynomial in standard form from start to finish without using a calculator. So the assumption is that you've been talking already about various important features of a polynomial, and now we get to pull all these different ideas together. So here we have a polynomial in standard form, and what you want to do is kind of think through what you're looking at. Like, in other words, this is a degree 4 polynomial, which means a couple of different things. It means that there could be potentially 3 turns on the graph, and that's a maximum of 3 turns, right? So a maximum of 3 turns. And another word for turns or turning points is going to be your mins and maxes. Okay, so those high and low valleys on the graph. We also know that there are up to 4 real solutions. Now, a solution on the graph is going to be your x-intercepts. Okay, so up to 4 x-intercepts. We also know, based on this leading term, okay, since it is positive and since it is even, we know the end behavior. So the end behavior, remember, is, what's going to happen on the left and what's going to happen on the right. It's a positive leading coefficient. It's an even exponent, so I know the graph is going up on both sides. Another way to write that would be as x approaches negative infinity, which this basically means to the left, the y is going up. And then if I want to say to the right, I would write as x approaches infinity. Now y is also approaching infinity. So just a couple of ways to write that. Okay, so I know what the ends are going to look like, and I kind of know generally what can happen in the middle. So what do I want to find? Well, for me, if I find the intercepts of the graph, I'm like really, really happy, okay? So what I'm going to do is first find the y-intercept, just because I think that's pretty dang easy to find. Then I'm going to go after my x-intercepts, which is a little more cumbersome. To find a y-intercept, remember, if you're on that y-axis, your x value is 0, and you're trying to find the y. So if you think of it as a coordinate, it should trigger you to take that 0 for x, and you can literally just plug it in. So basically, it's just, 2 times 0 to the 4th minus 5 times 0 cubed minus 0 squared minus 5 times 0 minus 3. And when you math that out, you are going to get a negative 3. So I know this graph is crossing at 0, negative 3. For my x-intercepts, well, if I'm an x-intercept, you have your x and your y is 0. So to solve for your x-intercepts, you're plugging in a 0 for the y, and you're trying to solve this. Now, some people learn how to factor really high-level polynomials. Most of us do not know how to do that. In fact, this one scares me. I don't know if I know how to do this. That was a cubed. So instead, what we're going to use is synthetic division to help us, okay? So this is going to pull in some division, and we're going to have to talk maybe a couple of theorems. But the big idea is I am wanting to factor this, if at all possible, and it could have up to 4 factors, okay, just because of that leading power. But to find these factors, what I need to know is that those factors divide into this polynomial evenly. So what does that mean? Well, if a factor divides into it evenly, it means one of 2 things. It means that if I do synthetic division with a specific number here, I'm going to get a remainder of 0. That's one way of thinking about it, because the division would have no remainder. Another way of thinking about it is if I take the function and plug in some specific number to the equation, I'm going to also get a value of 0. So we have both of these ways that we can try. I prefer the synthetic division way. Now, there's a lot of numbers out there, folks. So if we're going to start doing synthetic division and nobody has told us what to divide by, there is something called the rational roots theorem. I'm going to switch colors here. Rational roots theorem. And what the rational roots theorem says is that in order to find a list of numbers that could potentially be your x-intercepts or your solutions, you take the positive or negative version of the factors of the last term, so the factors of the constant that's at the back, okay, and you divide that by the factors of the leading coefficient. leading, y'all know coefficient is hard for me to spell, coefficient, there we go. So basically, the factors of the back divided by the factors of the front. And those numbers are numbers that we're going to try synthetic division with. So if I want to make a list for this problem, well, the factors of the back are, since that's a 3, the only numbers that go into 3 are 1 and 3. And in the front, there's a 2. So the only numbers that go into 2 are 1 and 2. And so basically, it's any version of what you see here. So in other words, it could be positive or negative 1 over 1, 1 over 2, or 3 over 1, 3 over 2. So we now went from having to try potentially every number in the world to try to get a 0, and we've narrowed the list down to these 8 numbers. Now there's 8 of them because you could do the positive versions or the negative. So what we're going to do is start trying to find the number, and I prefer doing synthetic division. So the way that I work it is I hate fractions just like y'all, so I would probably check positive negative 1, and then I would probably check positive negative 3 and hope that one of those works, okay? So in other words, so I usually start with 1 in the front, and then remember synthetic division, you just copy down your coefficients, okay? And my hope is that I get a 0. So sometimes you get lucky, sometimes you don't. So we bring down the first term, so I'm going to multiply, add, multiply, add, multiply, add, multiply. And that is definitely not a 0. So what that means is that 1 is not a solution. All right. So now I'm going to go try negative 1. All right. Negative 1. Okay. So negative 1 times 2 is negative 2. I'm going to add those and get negative 7. Multiply those. Now we're going to add, multiply those. Let's see, what is that? Negative 6. Oh, wait, that's going to be negative 6. And then negative 11. Okay, negative 1 did not work. All right, this is fun. All right, so now I'm going to move to 3. And then I'll try negative 3 if it doesn't work. So worst case scenario, you're doing this 8 times to figure out something that works. Hopefully we'll get lucky. 2 times 3 is 6. That's a 1. Multiply, add, multiply, add, multiply, add. Hallelujah. Okay, so what we did is we broke this down and we got a 0 to work. 3 works. So basically, here's what I've just learned. My list of x-intercepts are now 3, and I can find some more potentially. It also means that if I was to try to factor this problem above, that one of the things that would go into the parentheses is actually x minus 3. So remember how you change the sign when you go into parentheses? So we could also think of it that way. Okay, so now what we're left with, if you remember from class, this is now a 2x to the 4th plus 1x cubed plus 2x squared plus 1 with a remainder of 0. And what you do now is to try to find the other x-intercepts, okay? What we're going to do is synthetic division again with this, because unless you know how to factor this, which actually, you know what? Ooh, I do know how to factor that. But if you didn't know how to factor that, let me just tell you, you would use this same list of numbers and you would keep trying, okay? So you could even try, let's see, we haven't tried a half yet. We haven't tried negative 3. Actually, you know what? You wouldn't want to try negative 3 anymore or 3 over 2 because look at the number in the back. It's now a 1. So it's not a 3 anymore, so we know those aren't going to work. So probably positive 1/2 or negative 1/2 would work. Now, if you don't want to do that, you could factor, but you got to be good at factoring, right? So how do I factor this? Well, this is 2x to the 4th. Plus x cubed plus 2x squared plus 1. The way we could factor it is by grouping. I could group the front 2 and group the back 2. The common factor here is an x to the 3rd, and when I take that out, I get a 2 plus x. Sorry, I get a, wow, I don't get that at all. Hold on. It is early for me. I have not had my coffee. Okay, 2x plus 1. In this one, I can take out nothing. Well, that kind of stinks. Maybe I should have rearranged those. Boo, can I really not factor this? maybe I should have grouped it the other way. I'm trying to, sorry guys, I'm looking at this to see if I can factor this a different way. Dadgummit. Alright, I might not be able to see it. Sometimes this works where you factor by grouping and then everything works out. For some reason that wasn't working out for me, even though I swore it was going to work out. So bizarre. Oh, you know why? What the heck? Oh my gosh, y'all. I don't want to have to edit this video, but I feel like a freaking idiot. I forgot to subtract 1 from my power. So this is a good lesson in being very freaking careful. This started as 2x to the 4th. So this actually is now a 2x to the 3rd. Remember, we're supposed to subtract 1 from it. Y'all probably remembered that and you were yelling at your screen and I wasn't listening. So now I can factor this. I'm going to take an x squared out of the front 2, which means I'm left with a 2x plus 1. And in the back, there's really nothing to factor out, so I have a 2x plus 1. So what you do now is you take the common factor to both of those, which is 2x plus 1, and that's one of your factors, and then the coefficients are your other factor. Now, if you didn't know how to factor that, remember what I said, you could have just done synthetic division again with a 1/2 or a negative 1/2, so don't freak out if you didn't like that. So now I have all 3 factors. Earlier I wrote the x minus 3, the one that goes with the one that worked. So the equation I gave you, this is factored form. And if I want my zeros, well, one of them is a 3. One of them, if I set this equal to 0, would be a negative 1/2. And then if I set this equal to 0, I'm getting x equals the plus or minus the square root of negative 1, which hopefully we all know that is imaginary. So sometimes you get imaginary solutions, and that's what just happened. So I have 2 real solutions and 2 imaginary solutions that I can't put on the graph. But I have what I need to graph this bad boy because these are really x-intercepts, right? So I have 2 x-intercepts. I had a y-intercept above. Where was it? 0, negative 3. And I know my end behavior. So if I want to sketch a graph for this, 1, 2, 3, 4, 1, 2, 3, 1, 2, 3, 1, 2, 3, 4. Okay. I know the y-intercept was down here at 0, negative 3. The x-intercept is at positive 3, and then we have one at negative 1/2. Okay, so I know that on the left, this graph goes up. I know that on the right, this graph goes up. And none of the solutions showed up twice. Like, in other words, they don't have a multiplicity of 2 or 3, which means I cross through the axis. I also know that I can have either 3 turns if I want, or 1 turn. So what I'm going to do is just kind of make something that looks like a parabola. Now, I don't know how low this goes, and I don't know how skewed this is, but finding how low it actually goes is something that you're going to learn in calculus. So right now, if you meet the criteria of crossing those points and you know it's going up on both sides, we are so good to go. All right, so I know that's only one example, and if you feel good, push stop. If you don't feel good, I'm going to quickly go through another one that's a little less cumbersome, and hopefully, hopefully we will get through it quickly, and I won't mess up like I did just a second ago. So what are these? Okay, so here's our problem, and what are we going to do? All right, so I know that this is a degree 3. Which means we could have up to like a maximum of 3 x-intercepts. We could have 2 turns in the graph. We could have, we do have an end behavior. Since the leading term is positive and the exponent is odd, a positive odd, I know it's going to look like x cubed, so it's going to go down on this side and up on that side. Okay, so now I'm going to find my y-intercept. So the y-intercept is going to be, I plug in 0, so I'm going to do this in my head. So 0 plus 2 times 0 minus 5 times 0. So I'm only going to be left with that negative 6 at the back. So that was plugging in 0, mental math. My x-intercepts I'm going to find by doing that same thing from before. So I'm going to do synthetic division because I don't know how to factor this. And with doing synthetic division, I need to make a list of numbers that I get to use. So rational roots theorem time, guys. Okay, so I'm going to take the factors of what's in the back, which is a 6, right? So what numbers go into 6? 1, 2, 3, and 6, divided by the factors of the number in the front. And the number in the front is just a 1. So the only thing that goes into 1 is 1. So basically, I can try 1, 2, 3, or 6, or -1, -2, -3, -6. So I'm just going to start trying, okay? So maybe we try 1 first. All right, we've got 1, 2, -5, -6. Bring that down, 1. Now I multiply, now I add. Now I multiply, now I add, now I multiply. Didn't work, okay? So I'm going to erase that, and I'm going to go to -1. So same as before, you're just guessing and checking and hoping it works. -1 times 1 is negative. Now I'm going to add. Now I'm going to multiply. Now I'm going to add. Now I'm going to multiply. Yay! So that one gave me a 0. So I know faux show that one of my x-intercepts is the point -1, 0. Okay? Now, the leftovers, since this started as an x to the third, the leftovers are now x squared plus x minus 6. And that everybody in here should know how to factor. So we shouldn't have to do synthetic division again. We can just do this. So let's see, two numbers that multiply to -6, but they're going to add to the 1 in the middle. So that's a 3 and a 2. And that's going to be a +3 minus 2. Does that work? So FOIL it out if you're unsure to make sure it works, and this does. So my other x-intercepts are -3, because you're setting each of these to 0, remember, and then +2. All right, so I've got 3 x-intercepts. I know my y-intercept, and I know my end behavior. So that being said, let me erase this because I will just graph it all together right here so that I can see all my information. Okay. I know that I cross at -1, awesome, -3, and +2. Is that right? Yes. I know that my y-intercept is -6. 1, 2, 3, 4, 5, 6. So it's somewhere down here. And then what was my end behavior, okay? Well, it's down on the left and up on the right. So I'm going to go to my far left point and make it go down. I'm going to go to my far right point and make it go up, and then I'm going to play connect the dots. There will not be any bounces off the axis because none of those have a multiplicity of 2. These answers only showed up one time, which means if I put them back into their factors, it would look like this. And remember, if you, oops, that's a minus. If you are looking at factored form, guys, if it was going to bounce, hopefully you remember, you would see an exponent up here. And we don't see any exponents, so it's just going to go straight through. So it's going to go up, come back down, it's going to hit this point, and then hit that point. And like I said, you're guessing how tall it goes, you're guessing how low it goes, and that would be a good graph. All right, hopefully that helped you out, and it's all you need. Good luck with graphing. At the end of the problem, feel free to type it in on your calculator to make sure you did an awesome job. But knowing how to do these parts by hand is super important for SAT and college entrance tests and calculus class. Thank you.